Hey, so welcome to the second lesson on annuities, and this one is on calculating ordinary simple annuities. In particular, just concentrating on how to calculate the future value. So here's a nice example that you see on the screen, and I'll try to take this example and walk you through showing you what the formula is for the future value when you have equal payments or annuities. And then we'll try to solve these example, and then we'll do a couple more. So it says 10 years ago you decided to invest $2,000 at the end of each year in the stock market. Now over the 10 years the stock market has provided a return of 9.8% compounded annually. What is the accumulated value of your overall investment at the end of the 10 years? Okay, so how does this look like? So we have basically payments at the end of the year of $2,000, and we know that we have a compounded annually interest 9.8%. Okay, and this takes shape over 10 years, so basically we have 10 payments. So let me do a timeline. All right, so I'll do a timeline. I'll speed the video up so that you can see it. Okay, so I'll do that next. All right, so now we have our 10 payments. Okay, so we have these 10 equal payments. All of these payments are basically $2,000. All right, so they're all the same and they're spread out at the end of each year. So we have our start, which is right here, and then we have our end, which is right there. Now, once you have these payments and they're nicely equally spaced out, we want to be able to know, all right, so with these payments, what this is asking for is what is the accumulated value at the end of this entire term? So basically what we want to know is we want to be able to know what we have at the end of the entire term. So this is the future value after all the different payments have been made. Now, what we would have to do is, if you just thought about compounded interest and, for example, equivalent values, then our idea would be basically, all right, so let's take this one, let's shift it over. Okay, we'll shift it over to that future value. So our focal date is basically at the end of the year. And then, we will take this one, this particular payment, and also shift it over. Okay, and then we're going to keep doing that until we basically have all our different payments, okay, that are made. Okay, so what we would have, let me do that here. Okay, so we would have that, and then we would keep doing that, and we would move all of these different payments all the way to the end of the 10 years. Now, that's annoying, right? Because how would we do that? We would have to do them one by one. And so our future value would end up being, future value is equal to, now our first payment, so it's this one right there. Now this one turns out that it's exactly at the end, right? So it's right at the end. So there is no interest that accumulated on that. So this would be just our $2,000. So that would have been our 2K. Now the second one that we would have, let me clean this back up again. So this would be our second payment right here that we would have to shift over. Now this one we would be shifting just by 1 year. So what is the future value of that 1 year shift? So if you think back, okay, so that is your present value, so 2K, so that's the payment. Then 1 plus I, which is the interest, the compounding interest per period. In this case, it is annually. And we're just moving it 1 year. Now then after this, we would have to do the same thing to this payment. Now we would be moving it 2 years, right? 1, 2 years. So this would look something like this: 2k 1 plus I to the 2 years, and then we would have to do this continuously until we basically would do our final one. And in that case, so it would have been 3, this is 4, this is 5, this is 6, this is 7, this is 8, this is 9, and this is 10, right? We would have to do that 10 times. So here is our first one, here is our second one, here is our third one, and so on. So it turns out that the last one, because the payment is at the end of the year, so we would have to move it. So 2k, it would have to get moved, all right? So basically 9 terms over, okay? So that's what would happen. Now, sometimes students are wondering, why is it 9 and not 10? Because we have 10 payments. Well, the reason is because we are now have these payments at the end of the year. So notice, 1 year, move, 2 years, 3 years, 4 years, 5 years, 6, 7, 8, 9-year move. If that payment was in the beginning, okay, then it would have been 10. But in this case, it's at the end. And notice the title of our lesson, Ordinary Annuities. Ordinary means that the payments are at the end of each term. All right. Now, so this is something that we would have to calculate. Now, we can find it's 9.8% and it's compounded annually, so it is 9.8%. Just we would have to turn it into a decimal. But this would have been annoying, right? To do all of these calculations and then add them up. If you have only 2 or 3, not a big deal. You know, sometimes you can just kind of go through them. But 10 of them, or imagine, you know, you would have this over 20 years or 30 years. That would get really annoying to try to add all of these up. So in general, what happens is when you're dealing with these questions, okay, in general, your future value is simply your payment that you have. So whatever payment, okay, that you are working with, let me write, so payment, so that you carry, and then, so this, your payment in this case is $2,000, right? Now, then you would have to say, all right, so for the second year, okay, this would have been plus I to the 1, plus, and then dot, 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 all the way until, so this would be your general, okay, and in this case, okay, it would have been 9 because we're doing it over 10 years, all right? So that would have been n minus 1 in this case. So now where n is basically 10 years, and notice because we had the payment at the end of the term, then that becomes 10 minus 1, which became 9. That would be in general for any payments that you have at the end of the year and if you're compounding. Now again, so notice in the title, so what you have is, it's not only an ordinary annuity, it's also a simple annuity. So simple means that you're compounding, the number of periods that you have compounded in a year is equivalent to the number of payments that you have in a year. And in this case, it's basically 1. You have 1 payment per year and you're compounding annually. So we're just talking about ordinary simple annuities here. Now this equation, and what I'll do is I'm going to do a video in kind of lesson 2A and derive for you, for anyone who's interested. Okay, most people are not, unfortunately, or fortunately for you, so you don't have to think too much. But this can be nicely captured in a very concise formula. All right, and I'll do that in the next video. Okay, and then I'll put a card up above once that video is done. Okay, so here, okay, if you wanted to know what this general formula is, then your general formula, it turns out that for ordinary simple annuities, your future value is equal to, so this entire thing, so this right there, instead of doing it individually, okay, it turns out that it is simply your payment multiplied by 1 plus I to the n, which we're very familiar with. Okay, that's basically your compounding factor, minus 1 divided by I, which is your compounding interest. That is the overall formula that you have. How you come up with that formula, again, you can watch that video that I put up a link there for, okay, or watch lesson 2A, and I'll show you how to derive this formula. It's not that hard, but you have to know a little bit of some series math, okay? So if this is the formula, and now we have this question of these 10 payments, because our question is very specific. We're investing over 10 years. Now, over those 10 years, we have 10 payments. We know the payments are $2,000. We know the interest, which is 9.8%. So if you look at this, well, doesn't seem like such a big deal, right? We have the payment, we have I, so we can certainly find out what the future formula is. Now, just for those who are interested, okay, so this right here, okay, has a name to it, and it is the compounding factor. Now, we said the compounding factor was typically this, right? That was our compounding factor. But here, when we are referring to the entire thing, so into this bracket, so this bracket right there, then we call that the compounding factor of the annuity, okay, or compounding factor for the annuity. So that's kind of the name that you give it. And all it is basically, okay, what happens to if a payment was just $1? What would be its future value over all the different payments? Which is very familiar, okay, to those who studied the compounding factor, because compounding factor means the growth of $1 over time. And this means the growth of payments of $1 over time, because it is an annuity, and annuities, okay, have numerous payments, not just one. So to finish off this question, if we wanted to do this and actually solve it, then I can just plug in all the different numbers here and find out what my answer is. So my payment was $2,000, so that's my payment. And here this is 1 plus. Now I am compounding annually, so this is 0.098. Okay, my N, so number of actual payments that I have, so N is the number of payments in this case, or the compounding periods which align, so they're 1 to 1. So this is 10 minus 1 divided by 0.098, and then you can close the bracket. And now we can plug this into a calculator and find out exactly what the answer is. Let me shift the calculator on the opposite side. And how I would like to do this is I first compute the actual bracket itself. So what I'm going to do is I'm going to take, okay, so first this entire thing right there. Okay, so let's punch that in. So open bracket, 1 plus 0.098, close bracket. Okay, this is to the exponent of 10, and then minus 1. So that is exactly what I see there. So I'm going to hit equals. Now, some people like to write this down. I just let the calculator keep the answer. And now once I have the answer, so that's my answer. So now what I'm going to do is I'm going to divide it, okay, by, so divide it by 0.098. And that computes my entire bracket. So that's 15.78 and so on. Again, you can write it down if you like. I just leave it in the calculator because the last step is now I just have to multiply it by $2,000. So I'll take my answer and then multiply it by $2,000, and this is what I would have. So my final answer would be, in this case, 31,570. I'm going to round it to the penny, which is 77. All right. So that's how much you would have if you would be putting away $2,000. Now notice the interest is actually quite a bit, right? Because if you put $2,000 for 10 years, that's only $20,000. So that means over 11,500 was from interest that accumulates. And you can do that over a longer period of time, of 20 years or 30 years, and it's going to blow your mind away. Okay? So it's the power of compounding, and the power of compounding works the longer the time frame is. Okay? The shorter the time frame, it doesn't have as big of an impact. Okay, so that's this particular example that we have. Now, one note to students. So typically, if you're working on annuities, sure, you can work these out with a regular calculator. But really, you should be probably using a business calculator where you are basically inputting what the payment is, what the interest is, the number of terms that you have, and then you should be able to find your future value. And I will do a video on that as well, okay? And once those videos are done, I'll try to link them up. It's going to be in one of the lessons where we're just using a business calculator to calculate these, okay? Future values and so on. Now, here is another example, okay, that you have. So this example right here, and then I have another example just below it. Okay, so let's start with this one first. So it says Terry has to pay off a debt in 24 equal quarterly payments of $300. What is the future value of all the payments at the end of the term if interest is 8% compounded quarterly? So now in this case, okay, so it is 24 equal quarterly payments of $300, and we want to know what the future value is. We are working with ordinary simple annuities in this lesson. So that means that the payments are at the end of the term. And you can always ask if you have a teacher or a prof or something, if it's not being specific, right? When are these payments? Okay, so here let's assume that they're at the end of the term, and notice that the payments and the compounding align. So we are working with a simple annuity. So if I write this, now that we have presented the actual formula, then what I would do is the following. I would say, all right, what is given? Okay, do I know my payment? I do know my payment, so that's $300. Do I know my interest? And I do know my interest. It's 8% compounded quarterly. So this is 0.08 compounded quarterly, which means divided by 4, because there's 4 quarters in a year. So this we can actually calculate, 0.02. And really, if you think about it, those are the only two things that you need in order to calculate the future value, along with how many payments did you have. So we had 24 equal payments. And now if you take a look at the formula, the future value formula, so we can now insert this into the formula. So our future value is equal to, so that is, what is your payment multiplied by 1 plus, what is your I, 0.02. Okay, this is to 24, that's your N minus 1, and then divided by your interest, I. So all I'm doing is I am using this future value formula to plug in my knowns. Now, once you have this, this is just a matter of being able to use your calculator for it. So again, what I do is I literally will take this, okay, first. So it's easy to do on your calculator. If you have a regular calculator, you can use your brackets. So we have that to the power of 24 minus 1. I will hit equals to get what I have on top. And now my answer, I have to divide. So I'm going to divide by 0.02. So that gives me this. And now next, okay, so finally I take my answer and I multiply it by 300. All right, so again, so what I did was we divided by this, and now we're multiplying by 300. And that gives me an answer of $9,126.56. And that would be your future value at the end of the term. Okay, so that's it for that one. So now the last example that we have, so here's a car loan which is spread over 6 years, okay, and has dealt you a monthly bill of $750. So again, for ordinary simple annuities, we're assuming it is at the end of each term. Now it's 6 years and it's monthly. Okay, so be careful here because we need to know how many months in total this would be. And then our bill is $750 each time. And we know that the time value of money is 3.5% compounded monthly. And now we want to know our future value. So once again, when you're working with this, you say, all right, so what is given here? Okay, do I know my payment? So my payment is $750. Do I know I? So in this case, our I, so notice it's 3%, but it is compounded monthly. So that's over 12. And do I know the number of terms, right? The number of payments that I had. Now they align because it is an ordinary simple annuity. So in this case, it is 6 years times 12. And that, so 6 times 12, okay, is 72. So that's how many total payments I have. And now you can use your future value formula. So future value is equal to, so that is your payment multiplied by, now 1 plus I, which is 0.035 all over 12. Now notice I didn't actually compute it here because if I did, it would give me an odd, very small number. So I like to just keep it, okay, within there, kind of in a fractional form. Now to the power of 72 minus 1 divided by, and this would be divided by I, which is 0.035 divided by 12. And notice that now these formulas start to get a little bit hairy. Okay, because of the fact that you have these ugly interest rates. And that's why it's worthwhile, okay, if you're going to learn about annuities, it's also nice to be able to input what these actual numbers are into your business calculator. And I'll provide a video on that as well. Okay, so this time I'm just using your regular calculator so that you can see it. And I encourage you to try to find out what that actual answer is, right, on your own. Don't just watch me do it. So if I take out the calculator here, so let's move this over. So again, I'm going to first do, okay, so this entire thing. So this right here, I'm going to try to find out what the answer to that is. So open bracket 1 plus, okay, 0.035 divided by 12, close bracket. And that is to the power of 72 minus 1, okay, and then I hit equals. So I basically have now found what that is. And once you have this, now you can say, all right, so now my answer, okay, is divided by, so now it is divided by, but notice that you are dividing by this, fractional form. So what I encourage you to do is, if you have this, okay, if it was just a number, divide by the number. But now what I like to do is I'll say, okay, so divided by, and then I open the brackets, divided by 12, and I input it in like that, where I put the 0.035 over 12 in brackets, hit equals, and that gives me the answer to this. So now I have my answer, and then finally I will multiply by 750, and there we have it. So my final answer is, rounded. So let's round this back up. So this would be 70 cents. And that's what you would have as your final answer. Okay, if you were using just a plain regular calculator to calculate these ordinary simple annuities. All right. So in order to summarize, basically what we have is, for simple annuities, you're using this formula. Now, where it comes from, you can watch lesson 2, kind of A or 2B, I guess. And so you'll see that what that derivation of this formula is. But that formula just stems from the fact of having multiple payments over time. And it certainly is useful, in figuring out future values for anything. Investing, borrowing, okay, definitely play a role. Okay, so thanks for watching, and see you in one of the future videos. Okay, cheers, and hopefully we'll see you on the subscribe list.